Hello, in this video I'd like to introduce the one-lone coder PixelGameEngine 2, and I'm going to structure the video in the following way. I'm going to talk about the new features, I'm going to talk about why there's been a bit of a shift in design philosophy, and then I'm going to show some examples. But I do want to make it very clear from the beginning that PixelGameEngine 2.0 is fully backward compatible with PixelGameEngine any other version. So I know many of you have got projects and have started to use the PixelGameEngine. Don't worry, you can just drop this header in as a direct replacement and start to take advantage of the new features. I first created the PixelGameEngine about 18 months to 2 years ago. It was an upgrade of the one-lone coder console game engine, and it was developed purely as a tool for me to visualize algorithms to help me make videos. During that time, it's both been really pleasing and quite humbling to see quite a number of people have now adopted the PixelGameEngine as their preferred platform of choice for creating their own demonstrations and applications. And whilst on the whole the response has been very positive, there have been a few criticisms about its speed when it comes to drawing sprites, particularly high-resolution sprites, which some users have felt has impeded them from really realising the full potential of what they wanted to create. So I hope this update goes some way to addressing that problem. The PixelGameEngine has always strived for simplicity, and it's a single header file include into your project to get working. And if we have a look at its major features, the first thing it'll do is create a window. It then provides rudimentary drawing algorithms for drawing pixels on the screen. And there are quite a few different functions for this. You can draw circles, rectangles, lines, and triangles. You can also load images as sprites, and there are functions for loading sprite assets, drawing them to the screen, and scaling and manipulating them in various ways. There's also a basic functionality to draw text. And drawing all of these things is all well and good, but if you can't interact with it, you don't have much of an application, so it can also handle basic keyboard and mouse input. Critically, it can do all of these things cross-platform. And it'll do all of these things without requiring the user to install any additional frameworks. It's standalone. From an end user perspective, there are really only two things the user needs to do, and that is provide an implementation of a function called onUserCreate, which is called once at the start of your program, and then onUserUpdate, which is called every single frame, and the PixelGameEngine will run as fast as it possibly can, trying to draw as many frames to the screen as possible. And I believe this is a formula that works. People do seem to be using it, and people seem to be using it successfully. And I think when people do use it, they're often surprised that it really is no slouch, with frame rates in the hundreds if not thousands of frames per second typically achievable. After surveying a lot of user feedback, it would seem there are typically two common complaints. The first involves sprites. The PixelGameEngine handles sprites very well, but if you've got alpha blending, or you want to scale or rotate or in some way distort the sprite, that can become very computationally intensive. And whilst I applaud the efforts of those that have gone to great lengths to micro-optimize their sprite rendering algorithms to get every single last cycle of performance out of it, that's not an option that's available to everybody. The second highlighted area as a candidate for improvement is the cross-platform nature. Now, I've always ensured that PixelGameEngine will run on Windows and Linux with a basic development install, but it seems people want to port it to other platforms. And in its current form, the PixelGameEngine 1. whatever is not that easy to modify to adapt it to new platforms. One of the reasons sprites are a little slow is that the PixelGameEngine is pretty much entirely CPU bound. Yes, it does use OpenGL in the background, but all of these drawing functions and sprite drawing functions are fundamentally CPU operations, where the CPU copies memory from one surface to another. If the sprites are pixel and axis aligned and have no additional computation other than a copy, then that's quite fast too, but that's quite restrictive in terms of game development. And so for PixelGameEngine 2, we're going to leverage the graphics capabilities of your computer a little more by introducing a new fundamental primitive, the decal, which I want us to consider as a non-persistent sprite. And fundamentally, decals live on the GPU. So what exactly does non-persistent sprite mean? Normally, when we draw a sprite, it's drawn into a memory surface which represents the screen. The pixels of the sprite are copied directly into that memory, so if you draw it, it's persistent, it's there the frame after, and it will stay there until you explicitly remove it, or erase it, or overwrite it. A non-persistent sprite is slightly different. It exists only for the duration of that frame. Because it is never directly written into the frame, it is layered on top of it. From a technical point of view, this has quite a number of advantages. It means I can let the graphics card completely handle the rendering of that sprite object. One of the downsides is you can't interrogate the memory afterwards to see whether one of those sprite pixels was set, but in my use case so far, and I've not really observed any of the community doing it, not many people actually assess the pixels they've drawn on the screen. I think the only use case for that would be for doing some sort of pixel-perfect collision detection, and there are invariably better ways than just testing points on the screen to do that. So let's have a quick look at creating a decal and drawing it to the screen, and I'm going to go through the code pretty quickly in this video. I'm starting by using the now familiar standard basic PixelGameEngine application, where you override the PixelGameEngine base class, and you provide the two functions onUserCreate and onUserUpdate. In my main, I'm creating an instance of this derived class, and I'm telling it to construct a PixelGameEngine with a 640 by 480 resolution, where each PixelGameEngine pixel is 2 by 2 screen pixels. And then I start the engine. You can click the little link above for a video of how to install the PixelGameEngine in Visual Studio environments, but it's very simple. I'll start by creating a pointer to a sprite. And we need the sprite because that contains the image information. And in onUserCreate, I'm going to load that sprite. A decal is the new type of object, an OLC decal. And again, I'm creating a pointer to it. Decals need to be given a sprite as a source of the image information. So when I create my decal, in onUserCreate in this instance, I'm passing in the pointer to the sprite. Behind the scenes, this has the effect of downloading the sprite directly to the graphics card. If for some reason I change the sprite, and don't forget with PixelGameEngine sprites you can actually draw to them and manipulate them, then I'll need to re-upload the sprite to the graphics card, and I can do that via the decal update function. In onUserUpdate, I'm going to do some rendering. First thing I'm going to do is clear the screen. And I'm going to clear it to very dark blue. And just to make this demonstration a little bit interactive, I'm going to grab the mouse position on the screen. If I wanted to draw the sprite at the mouse location, I would call the drawSprite function, pass in the position, pass in the sprite, and we're done. We can run this. There we go. It's a very large sprite, this tree, relative to our screen. And we can see the frame rate's about 100 frames per second. However, the sprite should have a transparent background. Normally, if we've got transparency in the sprites, we would change the pixel mode accordingly. And I always advise if you do change pixel modes, always set it back to normal when you're finished, because doing this alpha blending calculation per pixel is quite costly. So let's have a look now. So now the sprite is rendering accurately, but we've dropped down to about 45 frames per second, and that's because it's a very large sprite. I can't scale down a sprite in the PixelGameEngine because then I would have to choose a particular sampling algorithm, and there are several and they all have their different advantages and disadvantages. Instead of drawing the sprite, I'm now going to draw the decal equivalent. And to do this, we use the drawDecal command. Again, I'm going to pass in the position, and I'm going to pass in the pointer to the decal. I don't need to specify a pixel mode when I'm drawing decals. If the sprite has alpha in it, it will be used regardless. So let's take a look. Well, here we've got the same end result, but the frame rate is now 3,500 frames per second. So hopefully it's obvious that by moving to decals we can really improve the performance of our applications. The drawDecal function has some additional arguments. We know the sprite was very large, so let's scale it to about a fifth of the size. I can do that by passing in an OLC VF2D, which is what this resolves to. That's better, we can see the whole sprite now. And rather ironically, our performance has gone up, we're now 3,700 frames per second. The final argument when drawing a decal, and both scaling and this argument are optional, is we can also supply a tint. by default it's tinted to white, but let's say I wanted to tint the sprite red. We've not sacrificed anything in terms of performance, but we've now changed the nature of the sprite. And in fact we can tint it to any particular colour by just passing through an OLC pixel. So if I wanted it to be all red and all green but no blue, so we're technically tinting it yellow, and I can also specify the amount of transparency as well. So a little bit tricky to see, but it's a little more yellow than the original sprite. Let's just play with that transparency value, so I'm going to set that to be quite low. And of course it blends with the dark blue background, but it's more transparent, and yet again we have not sacrificed any performance in doing this. So decals are really a fast way of rendering sprites in a flexible manner. I've also provided a function that allows you to draw a decal rotated. So here I'm going to add a variable to just keep track of an angle that will change over time. And I'm going to call the drawRotated decal function. And again we need to pass in a position. I'm going to put it where the mouse cursor is. I'm going to pass in the decal itself. And then I need to specify the angle. Each frame I'm going to increase my angle by f elapsed time, just so it changes. And so we can see the sprite is, well, it's large again, and it's certainly rotating. Even though it's large and it's rotating, we've not yet taken a performance hit. But it would be more useful if it rotated in a place that we understood. Right now it's chosen the top left of the image. I'd rather it rotate around the centre of the sprite. So the next argument in drawRotatedDecal allows me to specify precisely that centre position. And here I'm specifying it as a vector, and I'm using the source sprite to get its dimensions to tell me where the centre point of that sprite is. All of these vectors and positions are in pixel space. We're not working with normalised coordinates here. And as before with the standard drawDecal function, I can also provide scaling and tinting options. So I'm going to scale it back down again. So there we've got the sprite now rotating around wherever the mouse cursor is. If you're familiar with sprite sheets or atlases, sometimes you want to just draw from a particular source rectangle in that sheet. And you've always been able to do that in the PixelGameEngine with the drawPartialSprite function. In exactly the same way, I've also provided a drawPartialDecal function. But I'm not going to demonstrate that here. There is one final decal drawing function which I think people will use and abuse to great effect. And to demonstrate it I need to throw in a little bit more code. So I'm going to add in a standard array of 2D vector types, and that's going to hold 4 of those 2D vector types. It's called points. And I'm also going to add in a raw pointer to a particular vector, and it's going to be one of those locations in that array. In my onUserCreate function, I'm going to populate those points with some dimensions. Now I did promise I will rattle through the code quite quickly, but I'll upload it to the GitHub so you can explore it on your own later. I'm going to check to see if my current mouse location, when clicked, exists in the vicinity of one of those points on the screen. Effectively, this allows me to select that particular point and move it around the screen with the mouse. And to help the user know where those points are, I'm just going to iterate through the array and draw them as filled-in circles with a radius of 4. And this allows me to demonstrate the final decal drawing routine, which is drawWarpedDecal. And here we pass in the decal that we want to draw, and we pass in our array of 4 points, and you can pass that array in various ways. So let's take a look. So here we can see the sprite, and in the corners of the sprite I will have 4 circles, and I can use my mouse to click and drag one of these 4 circles around. And the warping drawing technique allows you to add artificial perspective to your sprites, and again you'll see there is minimum performance loss in doing this. The 4 points that we pass in are the 4 screen positions where you want the sprite to appear. And you can even do some funky things when you start passing in invalid point sets. I'm sure some people might find a use for that, but I'm not so sure yet. I can see this feature being used for animating sprites slightly, so if we wanted the tree to slightly blow in the wind, we could just manipulate these top 2 points. We can also change what the sprite looks like, so if I wanted it to be slightly more cartoony, I can specify the points as so. Now, whenever I've created a new bit of technology and made a video about it, invariably I find a way to destroy the YouTube video encoding algorithm, and so this code does exactly that. I wanted to see how many sprites we could really throw at the rendering system. So here we've got the PixelGameEngine 2 logo pulsating in the background. It's just being drawn with an alpha that changes. We can see the frame rate is about 800 frames per second. So if I click the mouse, we're going to throw a random assortment of sprites into the screen, we're going to tint the colour, and we're going to scale them as they bounce around. And I'm going to keep doing this. Now, most people's accepted standard of frame rate is about 60 frames per second. I think if you get to a point where you can render several thousand fully transformed, tinted, scaled and alpha blended sprites, you're probably doing okay. You can see around the edge here I've got them alpha blended depending on the X coordinate, so that's why we get this softer fuzzy edge here. So none of these sprites are being deleted yet, they're still just bouncing around even though they're being drawn on top of each other. And that's an important point to make, that decals are drawn on the screen in the order that you draw them in code, so they automatically apply the painter's algorithm. They're not sorted in any way. Now in the edit I'll speed up and slow down bits of this video because it's taking a while to get to a large number, but it's fun to watch. So now we've reached a situation where occasionally we're dipping to about 60 frames per second. And as you can see, it's drawing about 22,000 sprites. These are fully transformed and illuminated sprites. I think that's probably going to be enough for most people. But of course, your mileage will vary depending on how you use the application. In this case, my physics is very simple, it's just bouncing off the edge of the screen. As you add more complexity to the game, of course your sprite budget will diminish. So hopefully I've demonstrated that by using sprites directly on the graphics card in the form of decals, we can achieve significant performance upgrades. I'd like to talk about the next feature of the PixelGameEngine, which is the concept of layers, and these are entirely optional, but some people might find them useful to organise their rendering. The PixelGameEngine has always assumed that the screen is the primary drawing target. Its top left is 0, 0, and down here we've got screen width and screen height. In PixelGameEngine 2, this is now considered layer 0. And layer 0 always exists. However, sometimes it's useful to have additional layers, and so now you can do just that, and layer 0 will always be at the front, so if we added another layer we would have layer 1, which is the same size as layer 0, but exists behind it. And we can actually have many layers. Layers can be used for conceptually grouping various stages of your rendering. So, for example, you could have in layer 2 here right at the back a mountain scene. Layer 1 could be where all your game is happening, and layer 0 could now be some debug overlay or a heads-up display. All layers except for layer 0 can be toggled on or off. They can also be tinted in their own right. So if you wanted to change the overall tint of everything that's drawn in that layer, you can specify that explicitly. You can also offset a layer, so it's not necessarily drawn at the 0, 0 location relative to layer 0 at the top of the screen. One of the advantages of a layer is they are a little bit intelligent. Once you've drawn to a layer, it costs nothing more to render that layer. So let's say your game has a static background of a mountain scene, you could draw that into the layer in onUserCreate, and then it's done, you don't have to worry about it again. This means you could save those valuable cycles of having to redraw the whole screen every single frame. I will point out that there is nothing that layers bring that is new that can't be also achieved with decals, so they are more of a conceptual organising tool in the fact that you have things grouped together. And you choose different layers using the setDrawTarget method, so you can now use setDrawTarget to target sprites or layers. Let's have a quick look at adding a couple of layers to our demonstration application. To demonstrate the layer, I'm going to draw the PixelGameEngine 2 logo in the background. So I'm going to load the logo as a sprite. In our user create, explicitly load that sprite. I'm not going to create a decal of the logo, but I could and choose to render that first. Instead, I'm going to draw that logo into a layer of its own. Layers are identified as integers, and I will ask the PixelGameEngine to create a layer for me. It returns the ID, so they need to be created in the order that you expect them to be rendered. Remember, layer 0 always exists, and that's always at the top of the layer stack. I will explicitly target drawing to that layer only with the setDrawTarget function. And now we just treat it like a standard PixelGameEngine rendering process. We'll clear all of that background to white. I'm then going to set the pixel mode, draw my logo sprite in the middle of the layer, and then I'm going to enable the layer. So this will tell the PixelGameEngine that yes, I do want you to draw this layer when it's appropriate. And then I'll specify setDrawTarget null pointer. You can also specify 0 here. Now, what's quite important is we've just drawn into the layer here the logo, but that was layer 1. But layer 0, which is our default, the first thing we're doing is clearing everything to very dark blue. So that means we won't see anything in the layer behind this layer 0. So instead of clearing everything to very dark blue, I'm going to clear it to blank, because we want the transparency of this layer to allow us to see the layer that's underneath it. Other than that, it's going to carry on allowing us to warp the tree sprite. So let's take a look. And there we can see the logo in the background. I'll just move the tree out of the way. And yet in our onUserUpdate function, we never explicitly draw that logo. It is now cemented there as part of the layer in the background. And we can of course tint that layer also. Whether you use layers or decals, it's entirely up to you. I think in the future I might add in some additional functions to handle automatic blending between layers in interesting ways, such as perhaps additive transformations, that kind of thing. Anyway, that's it with the new graphical features. One of the things I want to talk about now is what's really changed behind the scenes in the PixelGameEngine to make it far easier to port to other platforms and systems. In the original PixelGameEngine, you were presented with an interface, and throughout that interface, scattered all over it, were lots of little hash if-defs. And that was to handle compatibility between different platforms. And what we would see is in this part of the code you'd have something for Windows, and then in this part you'd have something for Linux, and then maybe a bit of Windows here, and then a bit of Windows here, and then a bit of Linux here, and some Linux here, and some Windows here, and even possibly some code blocks, specific things here. So there were all these little fixes and patches just to make it work on different systems. As the PixelGameEngine has developed in sophistication, this has become quite tricky to maintain and makes the code somewhat unreadable. So the PixelGameEngine 2 has been pretty much a complete rewrite to abstract away this complexity. And so there's a bit of a philosophical difference now between what the PixelGameEngine actually is. The PGE core itself is now a genuine application programming interface. It's what defines all of the drawing functions and how they are used for the end user. And it sits on two additional modules. The first one handles the platform, and the second handles a renderer. The platform and the renderer can communicate with each other. So this means there is absolutely no platform-specific or renderer-specific code in the PixelGameEngine 2 API. For the platform, you can provide different implementations, and so far I've got one for Windows, and I've got one for Linux. Some of the guys on the Discord server are also looking at building one for Emscripten, which is effectively WebGL, so it'll allow you to run it in the browser. And of course, I'd really like there to be one for Apple. I don't have access to a Mac computer, so it's very difficult for me to develop that one. In much the same way, the renderer module abstracts away whatever rendering technology your system is using. So by default, the PixelGameEngine, and some of you will giggle at this if you didn't already know, used OpenGL 1. If you wanted to play around with pixel shaders or use the PixelGameEngine as a general purpose OpenGL interface, we are currently working on an OpenGL 3.3 implementation. And in the pipeline, we're hoping to have an OpenGL ES2 implementation, which should make migration to Android devices and potentially the Emscripten platform a little easier. But there's nothing stopping anybody coming up with a DirectX implementation. And indeed, I know that somebody did that for the PixelGameEngine 1. And sure, why not? For the hell of it, somebody I'm sure will come up with a Vulkan implementation, because they're masochistic. Now, it may be the case that a particular platform requires a minimum style of renderer, and so those small details need to be worked out. But the idea is that through encapsulation, we've now really simplified the process of porting the PixelGameEngine to different platforms. The API never needs to change in order to accommodate the different platforms underneath. So that's it for the major technical descriptions of the changes between PixelGameEngine 2 and its predecessors. I hope you'll find something useful in that. Now, I wanted to also produce some sort of demonstration to try out all of these new features for myself, and I started off with this. I wanted a simple scene that demonstrated some parallax scrolling and lots of rendering, so all of these blades of grass that are blowing in the breeze here are rendered separately. And I can actually change the time of day slowly, although we can see it changing at the top. That changes the tinting required. So here comes the sun. The sun is a regular fill circle, and I changed the tint on 2 layers of cloud sprites, so I can change the underside and the top side of the sprites differently. And I also changed the tinting on the landscape at the front, so all of the blades of grass that are rendered as decals are tinted accordingly. And then as it goes into nighttime, we change the gradient in the sky in the background, and we start to reveal some stars. And of course night passes and the sun starts to rise again. This time going through a different colour sequence to sort of emulate dawn. But then I thought, I'm not thinking big enough. And so I thought I'd try a little bit harder. Why not take advantage of the tinting to handle lighting conditions properly? Why not take advantage of the fact we can draw many thousands of sprites to draw every single blade of grass? Why not take advantage of decal warping to handle perspective? It's not a perfect demonstration by any means, but we can see that the graphical user interface HUD in the front is a layer on its own. We've got a background layer handling the mountains in the distance and the colour of the sky. And we've got a main game layer. We can see objects that come too close to the camera can become transparent so we don't lose sight of the player. We can also render very large worlds too. So if I move my camera upwards, I can pan around the whole world. It's not a very populated world other than this little forest. And we can see in the background the world kind of pops into view. Anyway, I hope you enjoy the updates to the PixelGameEngine in the form of PGE 2.0. Like with any new software, I'm sure there are going to be bugs that we'll find, and hopefully we'll get them changed very quickly. I look forward to seeing all of your wonderful and crazy projects over the next few months. Like with all new software, there are probably going to be bugs and things that we'll need to fix and find, and I'm hoping that the community might get involved in sorting some of those out. Anyway, if you have any trouble, come and have a chat on the Discord server. If you've enjoyed this video, a big thumbs up please to keep me going, and I'll see you next time. Take care.